Hi viewers, in this video we'll go through Cambridge A-Level Further Math Syllabus Code 9231, Component 1 of the syllabus, which is Further Pure 1. This is Variant 3 from the May June 2025 series. We'll attempt question 1 in this video, and it's giving us a transformation matrix M represents the sequence of two transformations in the Cartesian plane given by a stretched parallel the x-axis with a scale factor of 14, followed by a rotation anticlockwise about the origin through angle pi over 3 radian. So they want us to show that 2 equals to this matrix. So first of all, let's deal with the scale factor stretching first. So it says it's a stretching with parallel to the x-axis. So let's say let's call this matrix A first. So obviously if you have an identity matrix it's like that, and then if you map it onto a xy coordinate, it will come out as xy, right? So if you want to stretch the x-axis, so let's say we have a multiple and this one, so once you multiply it, then the the x-axis there will be multiplied by a stretch. So if the scale factor is 14, meaning this multiple will be 14. So after you map it onto the coordinate, so it will become 14x. So the x-axis it will be stretched, where the y-axis or the y-coordinate is just left by itself. So the matrix for the first operation, which is the stretch, there will be this one. Okay, so that's A. Now we want to deal with the rotation. So if you can, I think this one you guys usually memorize it, right? So the rotation matrix is this one. Okay, cosine theta, negative sine theta, and then cosine theta. For which theta, you just replace it with whatever angle that we rotate it by. So in this case, it's pi over 3. So we replace everything with pi over 3. And so we know cosine pi over 3, that is half. While sine pi over 3, that is square root 3 over 2. If you forget how to do that, you can just remember the unit triangle, right? Or the special triangle, you have a 30, 60, something like that. So the side there will be square root 3. This is one that is sorry, this one will be 2, right? This one will be 2, square root 3, something like that. So pi over 3 is 60, opposite, and then hypotenuse. So opposite is square root 3, hypotenuse is 2. So there is a sine. Okay, we continue with the matrix here. Okay, so now we have to do some multiplication with the matrix so we can get the combined matrix, right? Because this M is combine both of this transformation together. So now is the question whether A comes first or B comes first. We know that the stretch comes first before the rotation. So definitely remember, for matrix, the order of the matrix is the one on the right will start first. So we will start with A and then go to B. Okay, so that's how the matrix multiplication works. So 14, sorry, B is the one on the left hand side, right? So B is half, so 3 over 2, 3 over 2, 1 over 2, multiplied by 14, 0, 0, 1. Now for the matrix multiplication, if you forget, we take the row and then the column. So that will be the first the first entry into the matrix here. So 14 times half, that will be 7. And then square root 3 over 2 times 0, that will be 0. So there's just 7 in the first entry. Now, okay, that's the first one done. We erase this one. Now we take the second one again. We take the row, then we take the column, for which we will just get only, okay, 1 half times 0 is 0, square root 3 over 2 times 1 is just square root 3 over 2. Okay, next one. Now we move on to the second row, first column. So square root 3 over 2 times 14, that is 7 square root 3. Then half times 0, that is 0, so just one term there. And last one, we take last row, last column. So again, something square root 3 over 2 times 0, that's 0, then half times 1, that's half. Okay, so that's our M. But our question wants us to show 2M. So what we have to do is just multiply. Okay, this is a scalar multiple, so you can multiply everything just by 2. And yeah, if we get exactly the same in the, oh, I missed out a negative here. So when I transfer, I forgot to put the negative in front of the square root 3 over 2. So yeah, careless there, but everything is the same now, and therefore this is our final answer. Okay, that's question A. Moving on for question 2. Find the equation of the invariant line, through the origin of the transformation in the xy plane represented by M. Okay, so what invariant means is not varying, so it remains the same. So even though something, let's say we multiply M or we map M onto a xy coordinate, it will return us the same as xy. Okay, even though we multiply or we transform already, it will still give us the xy. So given that this is you want to find the lines, right, not just the point. I think we did in previous paper that was just finding the points, but in this case you want to find the lines. So we have the relation y equals to mx. Then also for invariant lines, even let's say after we multiply, it give us y prime equals to mx prime. So this one will still be the two what we call the two relation or the two pieces of information that we can use to solve this lah. Okay, so now we do the m first. Let's find out our m. So that is 7 negative square root 3 over 2, 7 3 and half. We multiply, we map onto xy coordinate. So yeah, we'll do the matrix multiplication. Okay, so this two is essentially our x prime and y prime, right? So x prime, that's giving us 7x square root 3 over 2y, then y prime is 7 square root 3x plus y over 2. And from these two, we're going to use these two substitutions to simplify our equation so that we can solve for the lines. Okay, first of all, let's replace all the y into mx. So x prime, this one. So mx, okay, this y we return it to mx, y prime 3x mx over 2. And then what else we can do? Since we know that y prime is mx, we're going to replace x into y. So again, m x prime, x prime is this one now, so I'm going to rewrite this entire thing, equals to the y prime, which is 7 over 3 x plus mx over 2. And now, okay, each term has an x, so I can cancel out all the x. Okay, we don't really care about the x equals to 0 case because we're not considering the, or I mean, everything you transform from the origin, there will still be, in this case, it does not, or it's not one of the thing we are interested in. Okay, so after you do the substitution, you should be able to get a quadratic equation in terms of m with some certs inside, which you should be able to factorize out. And the two values of m you should be able to get 7 over square root 3 and 2 square root 3, for which the lines you can substitute back into the again the question one, the equation of the lines, right? So you can substitute back into this one, y equals to this x, y equals to 2 square root 3x. So these are the two invariant lines for which this will be represented by the transformations. Okay, so these two is our final answer. And we move on to question C. Unit square S in the xy plane is transformed by M onto rectangle P. So meaning we have we have M, I think M multiplied by S equals to P. So you want to find a matrix, we transform P onto S. So meaning P multiplied by something will be going back to S lah. So it's something like an inverse of function. So it will be inverse M, which transform this back into S. Okay, so let me rewrite m first. So m is 7 square root 3 over 2, 7 square root 3 and half, right, if I'm not mistaken. Okay, if you can remember, I think this one is also something you have to memorize because it's not given in the formula sheet. Inverse of a matrix is 1 over the determinant of the matrix multiplied by the transform of the cofactor of that matrix, something like that. So we transpose it. Okay, so that is the general matrix inverse formula. But again, for 2 by 2, I think there is some simple or simplified formula for this, which does not in fact factor in the cofactor or the determinant, where it's just you have to do the multiplication, right? So determinant of a 2 by 2 matrix, just take this one, 7 cross multiplied by 1 over 2, then minus 7 over 3 multiplied by 3 over 2, 3 over 2. So, okay, 7 multiplied by 1 over 2 minus 7 square root 3 multiplied negative square root 3 over 2. Okay, to find the cofactor matrix, I'm sure there's some way of for you to memorize this, or there's something even more straightforward for you to memorize. But I'll go. This is the general steps for the matrix. So for the first entry, we take look at the first one again, and we cover the row, cover the column. So we have half here. Second one, we take cover the row, cover the column again, 7 square root over 3. Then for the third one, we cover 7 square root 3, row and column. We have negative square root 3 over 2. Last one, we just have 7. Okay, then this is just the cofactor matrix, so we still need to transpose it. To transpose the matrix, we leave the diagonal the same, but then we swap these two places. Okay, that's for the transpose. So this is for the 2 by 2 matrix, but if you have a 3 by 3 or 4 by 4, the steps is still the same. So that's why I prefer to just understand the general method instead of just taking like the square root 2, I mean the matrix 2 by 2 matrix formula, right? So this is the general one. So we keep the diagonal the same. So half 7, but we swap this one, 7 square root 3 negative square root 3 over 2. That's the transposed cofactor matrix. And this one, if you do the computation, that is 1 over 14. And yeah, this finally is your final answer for the inverse matrix of M. Okay, that's the inverse M. So yeah, that's the final answer. And thanks for watching the video.